Let's talk about those exponential problems that are like quadratic problems, the substitution ones. Those are ones, I'm going to write common like form it's in, but don't read too much into this. Because I think these are actually pretty easy to recognize when they come up. I'll use number 26 from that worksheet that you're doing for homework. I'll use as an example. That one says 5 to the 2x minus 5 times 5 to the x plus 6 equals 0. It's problems where you have a base to the 2x, a base to the x, and a constant. It's possible it won't be in this standard form. It looks kind of like a standard form type deal here. Maybe you'll have the negative 6 on the other side, or this term will be on the other side. Maybe you have to rearrange it, or maybe you have to play with it a little and distribute something before it turns into this. But once it's this, you see a base to the 2x, base to the x, and a constant. Maybe the constant's missing, it'll still be the same. Once you do that, you realize it's this problem type where you're going to use substitution. You're going to use substitution. The first thing you're going to do is you're going to rewrite the quadratic term. You're going to rewrite the quadratic term. By quadratic term, I mean the one with the 2x in it. You're going to rewrite it as something squared. You're going to rewrite it as 5x squared, because 5x is thinking a square to make this, because 5 to the x to the 2, exponents multiply, it makes 5 to the 2x. You do it like that because now this is an equation all about 5 to the x. We use substitution when we have a problem that's ugly and we want to replace the ugly parts with nice things, work on it, move things around while it's nice, and then later change it back into an ugly form. We use substitution so that instead of this 5 to the x, which is kind of scary, we could do an a. I'll plug it in and I'll say that this is a squared minus 5 times a plus 6 equals 0. Everywhere where I had a 5 to the x, I just switched it out for an a. And now I'm trying to solve this. This is a quadratic. It factors. Is it possible it won't factor? Yeah, quadratics, lots of quadratics don't factor. Problems of this type where it starts off like this, are we going to give you one where it doesn't factor? I don't think so. I don't know. Maybe the other Algebra 2 teachers are more mean than I am. They're not. They're lovely people. I'm going to factor this. It makes a minus 3, a minus 2 equals 0. And I've been totally neglecting to keep you updated on the steps. Before, my plan was I was going to write steps to solve. And the steps, one, we rewrote the quadratic term. What we did next was we did a substitution. That took us to here. And after we substituted, we factored. The reason we factored is because we're trying to solve for a. Or if one of the other classes, you're watching this video, my class we happen to use a because we used that the first time and then we just kept using it. Usually I'm going to have to use u, so maybe your teacher is showing it with a u. But you solve for whatever your substituted variable is. If a minus 3 times a minus 2 is 0, then a equals 3, or a equals 2. And now that we solve for a, we go ahead and now we solve for x. Do not be that person on a quiz or test that gets so excited about reaching this point you forgot to go back and actually solve the original problem. The original problem was all about x's. If you say a equals 3 or a equals 2, that has nothing to do with the problem. The problem didn't have an a in it. So to solve this now, I'm going to, if a equals 3 and a is 5 to the x, I'm going to say 5 to the x equals 3 or 5 to the x equals 2. So now I just have to solve these. These are quadratic equations of the second type, but really, I don't even really need to think about them. I really could just look at these and say I need to rewrite them in log form instead of exponent form, but they're problems of the second type. However it takes, you need to get from here to x equals. The thing I'm going to do to this to get to x equals is I'm going to do log base 5 of both sides. If I do log base 5 of 5 to the x, it becomes just x equals log base 5 of 3. Same with this one. I'm going to do log base 5 of both sides. And this becomes x equals log base 5 of 2. I know I'm writing this really squished. It's hard to read. I'm not used to writing things, making videos this way. But who are you complaining about hard to read? I'm making a YouTube video for you, and it's a Friday afternoon, so who needs your whining? Those are my answers. Sometimes at this point, you might get log of something negative. You might get like log base 5 of -3 or -9. If you're doing log of something negative, just cross off that answer choice. It's garbage. You don't need it in your life. You're better than that. And really, you could see it at the line before. If you have 5 to the x equals and then you have something negative, you should already say, this is not going to take me down any correct path because 5 to the x is never going to be something negative. I think I'll end the video here, but I'll make another video where I do lots of practice problems, like practice of this type.